Hello and welcome to the Data Engineering Podcast, the show about modern data management. Are you bogged down by having to manually manage data access controls, repeatedly move and copy data, and create audit reports to prove compliance? How much time could you save if those tasks were automated across your cloud platforms? Immuta is an automated data governance solution that enables safe and easy data analytics in the cloud. Their comprehensive data-level security, auditing, and de-identification features eliminate the need for time-consuming manual processes, and their focus on data and compliance team collaboration empowers you to deliver quick and valuable data analytics on the most sensitive data to unlock the full potential of your cloud data platforms. Learn how they streamline and accelerate manual processes to help you derive real results from your data at dataengineeringpodcast.com/immuta, that's IMMUTA, and get a 14-day free trial. And when you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode, that's LINODE, today and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Barr Moses and Lior Gavish about observability for your data pipelines and how they are addressing it at Monte Carlo Data. So, Barr, can you start by introducing yourself?
Yeah, hi everyone. Great to be here. My name is Barr Moses. I'm the CEO and co-founder of Monte Carlo. We are, as you mentioned, a data reliability and observability company. We are dedicated to accelerating the world's adoption of data by eliminating data downtime. Super excited to talk more about that topic and all this great stuff. Previously, I was VP at Gainsight, which is a customer success platform where I work with enterprise customers on using data as a competitive advantage and have been in data in the last decade or so.
And Lior, how about yourself?
Hi, everyone. I'm Lior. I'm Barr's co-founder and the CTO of Monte Carlo Data. I focus mostly on product and engineering at Monte Carlo. Before that, I was SVP engineering at a cybersecurity company called Barracuda, where I did a lot of work around fraud detection using machine learning and kind of experienced a lot of the pains that today we solve with Monte Carlo's solution.
And going back to you, Barr, do you remember how you first got involved in the area of data management?
Yeah, definitely. So I was actually born and raised in Israel. And so at the age of 18 was drafted to the Israeli Air Force. Did a lot of stuff with data there. Among other things, was a commander of a data analyst unit. And so worked with sort of real-time data for IDF operations. I moved to the Bay Area about a decade ago. And after that, I was a consultant at Bain & Company. Worked mostly with Fortune 500 companies on their data strategy and operations. And then at Gainsight, I led the team that was responsible for our customer data and worked with our customers on helping them unlock their customer data. I've been fortunate to work with data and data management in a number of different environments.
And Lior, do you remember how you got involved in data management?
Totally. So originally, I worked a lot on kind of machine learning. I did it as early as the 2000s, some of the earliest machine learning startups. Then later on, when I came to the Bay Area, which was also about 10 years ago, I started a company in the security space. We used analytics and data and machine learning to help detect fraud problems. The startup was acquired by Barracuda Networks, which was back then a public security company. And there we actually expanded our team quite a bit, ended up being around 80 engineers and product managers, all working on products that heavily rely on data and data pipelines. So that's kind of how I got a lot of exposure to challenges and opportunities with data management. And that's where I really got excited about the idea of starting a company with Barr around that.
When you were mentioning the work that you're doing at Monte Carlo, Barr, you used the term data downtime. I'm wondering if you can dig into that a little bit and some of the ways that it manifests in data workflows.
Yeah, definitely. So starting with the definition of data downtime. Data downtime is basically periods of time when data is missing, inaccurate, or for any other reason otherwise erroneous. And data downtime today affects all data-driven companies, regardless of industry. It's a very costly problem for many data teams. In fact, companies lose millions of dollars per year just firefighting bad data issues. It impacts, organizations small to large to governments as well. Actually, not too recently, it was published that the government sent no less than $1.4 billion in checks to dead people because of data downtime. On top of that, data teams waste north of 30% of their time troubleshooting data issues. Now, why do we actually think that this is a problem that's worth thinking about, other than kind of the impact that it has, or kind of where does the name actually come from, data downtime? Actually, I'll draw a corollary to application downtime. Application downtime is something that everyone is familiar with. So I'll take you back, a couple of decades ago, maybe 20 years or so, if a company had, their website was down, probably nobody noticed, right? Like, I'm not sure if anyone was looking at your website. Application downtime wasn't a big deal because no one was really watching that. But today, it kind of sounds ridiculous, right? If your website is down, it's a huge deal. If your application is down, it's a huge deal. And so there's this whole massive industry that has emerged to help manage application downtime. And there's entire teams, DevOps teams, that manage application downtime. If you look at the data industry in particular, I think the same thing is happening in data. So if you think about it today, or maybe a few years ago, you could get away with data being wrong in some places, perhaps some issues in some areas of your data stack. Maybe some reports are wrong. Maybe some tables in your data warehouse are not quite accurate. Maybe one or two sources have failed to load today. You can maybe get away with that. But today, and in the next 5 to 10 years, I don't think that's going to work anymore. I don't think that, we're going to be able to have these prolonged periods of data downtime. And so I think in the same way that in the last couple of decades, we've evolved as an industry to manage application downtime, now we need to evolve as a data industry to manage data downtime. And that's really kind of how we think about data downtime as a concept and where the term comes from.
And another term that I've seen used in some of the blog posts and other material that you've been putting out is the idea of observability, which, as you mentioned, is something that has come about from a lot of the work happening with DevOps and application reliability. And I'm wondering what that means in the context of data workflows and data applications and some of the types of information that you're monitoring to be able to gain observability into what might be causing these downtime issues for data applications and data analyses.
Right, you're spot on. So going back to the analogy for data downtime and application downtime, observability has emerged as sort of a fast-growing area to support DevOps teams to manage application downtime. And basically, DevOps teams use observability to help manage their applications and gain visibility into the health of their applications, basically optimize uptime, right? In order to do that, there's a standard set of metrics that they use, a various number of metrics and methodologies, just a few examples, measuring performance, latency, CPU, et cetera. But there's a whole sort of set of kind of methodologies around observability that are very, very well known in software and have really developed in the last couple of decades. Now, if you take that idea and you apply that to data observability, it actually makes a lot of sense, right? If you look at the data stack today, it's a complex system where you basically have, anywhere between 5 to 50 or 1,500 different kind of steps or systems. And it's really, really challenging to get visibility into the health of your data in that system, certainly in an automated way. And so we think that, data observability is basically an organization's ability to really understand the health of data in your system, which, by understanding that, you can ultimately help reduce and eventually eliminate data downtime. And so in order to create that data observability, you really need end-to-end data observability, all the way from when you first generate data, from when you ingest data throughout the transformations, and all the way to actually analytics, where your machine learning models, where your data scientists and end users are actually consuming your data. So in order to really ensure sort of the reliability and health of your data, you need to think about, what we call end-to-end data observability. And that includes instrumentation, monitoring of your data, analytics of that, of kind of the metrics, what you're looking at, remediation workflows when there are issues, all these different components, which together help create reliability of your data health.
And in terms of the contributing factors that lead to these issues of poor data quality and data downtime, what are the ways that that manifests in the different stages of the overall data lifecycle? And are there any stages in particular that have an outsized impact on how bad of an effect that has on the downstream analysis or the utility of the data?
Yes, absolutely. There's a bunch of different factors that play into this. And unfortunately, there's no silver bullet here, right? So some of the factors that are contributing to what we call data downtime, the first is actually the idea that companies are increasingly using very many sources of data to feed their analyses. So it starts with various internal applications that send their operational data to the data team for analysis, continues with information from various SaaS platforms that serve different parts of the business, like Salesforce or Zendesk or others, and then continues with information that companies pull from third-party data sources to feed their products and their analyses. The fact that there are so many data sources creates a lot of complexity because every single one of these data sources can change in unexpected ways and in ways where the data team does not control and may not have visibility into it. So, for example, if one of the engineers building one of the applications that the company uses makes a change to that application, maybe even like a small change, like adding a field to the schema, the data team is impacted by that. And it's really, really hard to keep track of all the changes that are happening across the organization and outside of it and adapt the analysis accordingly. So that's definitely a contributing factor. And we hear about it all the time. An engineer made a change, or a marketer made a change, or sales made a change, or a third party made a change, and we didn't know about it. And so our pipelines broke. So that's definitely a big factor here. Another factor that's increasingly an issue is that the analyses are increasingly complex. People are building pipelines that sometimes have dozens of steps from source to data product, right? To the dashboard or to the machine learning model. And every single one of those steps can materially impact the reliability of the data. So any change made to any of these steps can break the system in unexpected ways. And we see that happening all the time as well. The third factor is actually the fact that data teams are growing in size. So it's not uncommon anymore to see data teams that actually can have more than 100 people or even 1,000 people building the data stack, building pipelines, building analyses. And at that point, it becomes impossible for any one person to really fully understand the system end to end and to really understand the implications of a change on all the downstream consumers. And so all of these things together can create a lot of issues with data. And that's why essentially observability is so important, right? So the idea of being able to monitor the system end to end, collect metrics that can help teams understand the health of the system, can help team understand the dependencies in the system, and then a set of tools that allow them to collaborate around it and understand how they're impacted by other teams and how they impact their downstream consumers.
For observability and monitoring of quote unquote traditional software applications, that's for the most part a fairly well understood problem. And there are a number of solutions that have been built out for that. And there are a number of ways that you can compose those different tool chains together. I'm wondering what you have found to be some of the ways that monitoring and observability for data applications and data systems differs from the more traditional software applications that we might be familiar with deploying and maintaining.
Yeah, so there's definitely many similarities, but a few key differences. Starting out with the tooling and the mechanics, we said this before, but, I would say in this area, in the data space, we're probably about, 10 or 20 years or so behind in terms of software engineering. And just now, teams are starting to embrace things like automation and testing and monitoring and all these things that have been really kind of the bread and butter for DevOps. One of the key differences is actually the personas involved. So when you think about data observability, the folks who are both involved and responsible and want to understand things like what needs to be monitored, what data assets depend on others, when there's a change somewhere in the system, what are the data assets that are impacted, and should I care about that change at all? Do I need to know about that? those people are folks who, can include a variety of roles, starting from engineers who are building a data platform to data engineers who are responsible for the ETLs and pipelines. It could be data scientists who are actually using data for research or for modeling. It could be data analysts who are creating reports, reporting on, generating insights to drive the business. Or it can even be business users or executives in specific functions like marketing or sales or support who are actually consuming the data, perhaps even on a daily basis, to make these decisions. So really anyone who creates or consumes data needs to be involved, which is obviously very different from kind of traditional software systems. I think probably the second change is the outcome and impact of sort of data downtime versus application downtime. I remember I was speaking to, an e-commerce company, the head of data at an e-commerce company, and he told me, when the data on our website is wrong, it's actually as bad or even worse than when our website is down. I think in today's world where really sort of data drives our applications, when there is data downtime, it's incredibly costly for the organization and it impacts, a totally different set of people. And then I would say finally, on sort of the measurements and the metrics specifically that you'd want to monitor and analyze for data observability, we actually had to kind of define what those are. And so there's sort of 5 pillars that we believe in: freshness, distribution, volume, schema, and lineage, which kind of together give you a holistic view of observability. And those are obviously very different things than what you'd measure traditional software.
And that's also compounded by the fact that all of these systems are reliant on software that we write and deploy for being able to manipulate these data flows and handle transformations and handle data loading. And so in addition to those 5 pillars that you mentioned for the aspects of the health and well-being of the data, we also need to correlate that with the observability metrics of the systems and platforms that we're using to process the data. And so I'm curious what you have found to be some of the particular challenges of that, or if the existing observability systems are able to handle that correlation because of the fact that it's all a time domain problem.
It's a great question. Honestly, we found that correlating it is a huge challenge. I'm not even sure it's been fully resolved in the application observability space. What we need to do first is actually create observability in the data that flows through those systems. So as you mentioned, at the end of the day, data systems are software systems, and there's great tooling to track software and infrastructure. The gap that we kind of see is the ability to track the data that flows through the system, right? The idea of garbage in, garbage out. If you can't track the data as it go through the different steps of a pipeline, you might end up with data downtime and with broken data products. And so most of our efforts are around building visibility into that part so that teams can actually correlate that with application observability stuff, as you suggested. And so our approach has been very similar to what a lot of engineers have used tools like New Relic or Datadog. So we built the equivalent of that for data pipelines, right? The idea of one platform where you can aggregate a lot of observability metrics about the data that's flowing through the stack, and then use that information to monitor for issues, to detect various health issues, and then to troubleshoot and resolve them very quickly using that information. What we also found was that actually having observability can prevent a lot of the data issues in the first place. And an example of that is, Barr mentioned one of the observability pillars that we strongly believe in is lineage, which is the idea of being able to understand the dependencies between different data assets. So like starting from maybe a dashboard that an analyst has built on a BI tool and going back into the tables that are queried by that dashboard, and then the tables that feed those tables upstream, et cetera, and all the way to the source. Now, what we found is that the fact that we add that visibility and allow teams to understand how different assets depend on each other actually allows them to be responsible, right? And make changes to their system in a way that doesn't break any downstream consumers, and which allows them to move faster and maintain a higher degree of reliability in terms of their data products that they produce.
In terms of the observability of systems for software applications, it sometimes requires instrumenting different areas of the code to be able to understand what's happening at the different points, figure out things like timing, or using things such as tracing, where you have a sample of the data as it propagates throughout the different stages of the system. Is there a similar analogy to data observability where you need to instrument the data applications or insert some sort of tracing record that you can track as it propagates through the different layers of the data workflow?
Totally. So one of the kind of main ideas behind the Monte Carlo platform is that part of instrumentation, right? And the idea of connecting and integrating with the stack. And quite like application reliability, the idea is connect to the existing stack. Don't ask people to migrate to another solution. It needs to work with the stuff that people already use, that people already have in place. And by pulling information and metrics from those systems, we're able to create that observability, right? So to your question about tracing and adding records, at least in the data observability case, we're able to do a lot of the tracking without introducing any changes to the data system. And the way we do that is we're able to automatically track the history of how data has been used. So for example, we can track historical records of, for example, SQL queries on the data. And by examining those records, examining how the data was used, how it was written, we're able to create what is the equivalent of a trace in the system fully automatically without having to modify the records.
And in terms of the platform that you've built for being able to collect and analyze and display this observability information and the potential error points in the systems or raise alerts to the relevant teams, how have you architected that overall system and addressed the problem in the Monte Carlo platform?
So for us, the way that we think about solving this problem, sort of as Lior mentioned, is with end-to-end observability. So I think in the past, the sort of common thinking around this was sort of garbage in, garbage out, right? Which meant that whatever garbage you use or whatever data you ingest, you need to really think about that quality because that's kind of going to determine the quality of your data going forward. However, with the complexity of the tech stack today, that is no longer sufficient. You can ingest data that's perfectly clean, but then something might change along the way, which might cause your data to be corrupted, and you'll end up consuming data that's actually bad quality. And so because of that, we actually think about the different places in which data downtime can occur. It can happen upon ingestion. It can happen in the data warehouse if you're updating a table. It can happen if you're actually migrating to a new data warehouse. It can happen any of your Looker or Tableau dashboards. And because data downtime can happen anywhere across that stack, when we think about how to solve this problem, we need to think about this in an end-to-end way. It doesn't stop at sort of the garbage in, garbage out. That's first. Now, second, what kind of drives sort of the approach here is sort of the 5 pillars that we talked about. So I'll talk a little bit about each of them. So freshness. What does freshness actually mean? Freshness helps us determine how up to date your tables are. So if there's a table that you expect to see new data from, on an hourly or daily basis, and then suddenly data doesn't arrive, then there's potentially a freshness problem that you'll want to look into. The second pillar, which is distribution, which, is probably a collection of a number of different aspects to look at the data itself. One of them is whether the data is within an accepted range. So if you've typically seen a specific field to be within, the numbers 5 to 50, and then suddenly it's at 1,000, say it never made it to that number before, then that's probably kind of an issue with that particular field that you want to be aware of. The third pillar is volume, the completeness of your data tables. If you expect a certain number of, a number of rows or a file size, and it's wildly different today, you'd want to know about that. The fourth is schema. And so that can be, any sort of changes that are being made to your data. If a column is removed or changed, if a table is deprecated, et cetera. And then finally, lineage really helps bring all of this together. Lineage, where you're basically mapping your upstream and downstream dependencies. So for any given data assets, you can know here are all the different sources and different transformations that are upstream that are feeding this particular data asset. And then here's everything downstream that's relying on this. Lineage actually helps us bring kind of the whole story of these 5 pillars together so we can actually paint a picture and understand, okay, there's potentially a freshness problem here upstream, which is kind of related or impacting this distribution problem in a table downstream, which actually relates to this report in particular, which is being consumed very often. And so kind of thinking about these sort of 5 pillars together give us a good view of data observability, and then applying that end to end to your data stack is really how we think about sort of solving this problem of data reliability.
And as far as integrating into a customer's data stack, are there any particular systems that are easier to get information from, or any that are particularly difficult to be able to gain visibility into? I know things that, like Kafka, for instance, have historically been somewhat difficult to be able to understand what's actually sitting resident in a given topic, for instance.
Yeah, totally. There's definitely places where it's easier or harder. I'd say at a high level, the more cloud-based and modern the system is, the more likely it is to be observable using APIs that we all like to use and using kind of modern models of permissions and of logging and metrics. The more you go into the legacy area and kind of on-prem technologies and older versions of warehousing or BI tools or pipelines, the harder it becomes, right? Like, these systems may not have an API that you can really use, or it might be very limited. Those systems tend to be less integrated with source control and kind of like more modern development lifecycle tools. And they also tend to differ quite a bit across deployments, right? So just to contrast, if you're using a technology like Snowflake or BigQuery, everyone has the exact same version of it, the exact same deployment. It's all very consistent. Whereas if you look at older technologies that the customer may have installed on their own and managed on their own, you might find a wide range of versions, a wide range of deployment models. And that's definitely more challenging in terms of connecting to that and pulling out all the information that's necessary in order to create end-to-end observability. Having said that, it is possible to connect to most of those systems. And we've really spent a lot of our time on making sure that we can very easily connect to all these systems and also collect all the metadata and the metrics that we need in order to create observability. And this is indeed an area where we invested a lot of resources and where we add a lot of value to teams, because doing that instrumentation is definitely a challenge and definitely requires a lot of engineering investments.
Today's episode of the Data Engineering Podcast is sponsored by Datadog, a SaaS-based monitoring and analytics platform for cloud-scale infrastructure, applications, logs, and more. Datadog uses machine learning-based algorithms to detect errors and anomalies across your entire stack, which reduces the time it takes to detect and address outages and helps promote collaboration between data engineering, operations, and the rest of the company. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial. And if you start a trial and install Datadog's agent, they'll send you a free t-shirt. Another element of data systems, beyond just the functional aspects of being able to move information from point A to point B or query it and answer a given question, are the so-called non-functional aspects of it, such as data governance, compliance issues, security. I'm wondering if there are any aspects of the observability of the system or any of the information that you're collecting that can help feed into those goals as well.
Yeah, absolutely. So I would say you basically listed kind of the top challenges in data today. I think in all of these areas, data compliance, data security, data governance, data reliability, data quality, these are burning issues. And they've become more and more sort of a burning issue, in most recent years for a number of reasons. Maybe the primary one is actually how we use data today, which is very different than how we use data in the past. So, in the past, maybe a decade ago or so, people would use data, maybe they'd look at their data like once a quarter when they're, when the finance team is sort of reporting on numbers or something like that. And so there's a very small number of people who's looking at a pretty small data set and a handful number of reports that they're using to kind of, look at the business and make decisions. The world in which we live in today is incredibly different. So we have, very many data sources, very many people looking at data, and they're looking at it all the time in real time. And more companies are moving to that model. And because of that drastic change, we need to ensure sort of the highest bar for that data being secure, regulated, and governed. The other thing in which we were lacking is automation on all of these areas. And so when you think about automating data reliability and data quality, there's certainly, aspects of security and compliance and governance, which are very relevant, which sort of get automated as well. So all of these topics are topics that, we think a lot about and that are very, very near and dear to our customers. We see that every day.
And for somebody who is onboarding onto Monte Carlo and starting to integrate your system into their data platforms, what is the overall workflow of being able to get up and running? And what are some of the concrete outcomes of getting set up with Monte Carlo in terms of being able to gain better visibility or set up alerting and pager rotations for critical issues, or some of the other aspects of going from having little visibility into their systems or using some homegrown solution that they may have cobbled together from various other platforms to using Monte Carlo and getting a more holistic view of how data is propagating throughout their platform?
Yeah, in terms of implementing Monte Carlo, it's actually fairly easy, and we spent a lot of time making it very, very seamless for our customers. So essentially the way it works is we would create a read-only API keys or users on the various parts of the data stack, starting from BI tools, systems like Tableau or Looker, and through a data warehouse, whether it's Redshift or Snowflake or BigQuery or another, and all the way down to data lakes and even streams, right? So from the user's perspective, they would create an API key for us, and that's pretty much it. At the moment we have those API keys, all the rest is pretty automated. We automatically collect all the metadata, all the metrics, all the logs that we need in order to create observability. And so many of our customers can actually get started in pretty much less than 20 minutes. And then we do the heavy lifting of instrumentation, of benchmarking the system and understanding what a normal baseline might look like, and then exposing all of that to the customer using our dashboards, using notifications. And maybe Barr can tell us a little bit about how customers are experiencing it and how they are deriving value out of it.
There are sort of three key areas. The first is actually being able to automatically know about and detect data downtime. So in the past, if you typically found out about data downtime from potentially a consumer of the data downstream, like a data scientist or a data analyst or a business user, or potentially you even heard about it from a customer, found a problem with your data in your product, right? That's something that happens as well. The first thing is to actually know about data downtime and be the first to know about those issues. And so by having observability at your fingertips, you're able to understand and identify data downtime before it propagates downstream and impacts your business and your customers and can be very costly. That's the first item. The second is actually, once there's an issue, being able to resolve that in a matter of minutes instead of what can take easily weeks or months today. So, we see many data teams that oftentimes find out about a data issue, a few weeks or a month after it happened, only to then spend a few more weeks or a few more months trying to figure out what the root cause is. Now, the problem is that the longer that the problem lingers, the more time it takes to actually resolve it and to spend time, potentially backfilling the data, et cetera. And so the second key thing here is being able to resolve in minutes. And then the third is actually preventing these issues to begin with. So when you have this data at your fingertips, when you actually have this visibility into the health of your data in an automated, scalable way, you can actually prevent all of these to begin with. And that's one of the most interesting things that we've seen. And I think that if we, continuing in this track, we should get to a place, as an industry where we can actually trust our data. I know that sounds like a sort of a crazy concept today. People have sort of, gotten used to the idea that the data is broken here and broken there. And, we're just going to, such is life, bad data exists. I don't believe in that. I really think that we need to get to a place in the world where we can trust our data and we can use it to make decisions in real time. And I think data observability is the key to getting us there.
In terms of any either horror stories of situations that you found yourself in at previous organizations where data downtime became a problem, or homegrown solutions that you've seen built to address those types of problems, or some of the most interesting or innovative or unexpected ways that you've seen teams using Monte Carlo or their own systems for being able to identify and address these observability and downtime issues?
Yeah, for sure. There's so many data downtime disasters, all the way, from, teams that just, wake up every morning and just get started on the daily data fire drill, or, a CEO that would kind of go around the office and would sort of put like a sticky note on monitors and reports saying like, this data is wrong, or a customer that, left a vendor because the data was wrong. Right. And so resulting in kind of material impact on that company, or a company that was at a compliance risk because the data that they were tracking, the financial data they were tracking, was inaccurate. So definitely, if you've been in data, you for sure have a data disaster that you can tell about or that you remember. And yeah, in our experience, we've spoken with sort of hundreds of data teams about this problem. And we've actually kind of collected all of the different ways in which teams deal with this and how they think about this problem, and actually plotted what you would call sort of a data downtime maturity curve or journey. And we found that there are sort of 4 key stages that kind of typical company goes through. The first stage is where, you'd call it the reactive stage, where really you don't quite have anything to ensure the quality and reliability of your data. And for that, I think that's something that probably a lot of listeners can resonate, but it's very hard to know what data can be trusted. It's very hard to know what data is important and what's not, what's used and what's not. And really, you are kind of playing this game of whack-a-mole, trying to figure out, where the next data fire drill is going to come from and how quickly can you resolve that. This can happen even on a daily basis or a weekly basis. This oftentimes happen at the same time when organizations try to become more data-driven. So it's actually a good problem to have. It means that you are doing the right things with data, but you still haven't gotten to the part of sort of figuring out data reliability yet. And that's when people start sort of moving into the proactive stage, where data teams actually start putting some probably manual, either testing or checks. Can be something, pretty basic, like looking at row counts, which sort of starts to give data teams some visibility into, some symptoms of what happens when data goes wrong. Obviously, that kind of the challenge is that you will probably spend a lot of time in kind of postmortems to figure out, for every fire drill, what is kind of a particular kind of test or monitor that I need to apply now. But starting to think about this in a proactive way is sort of the second stage in an important shift in a company's life. The third stage is kind of the automated stage, where companies actually start hacking their own solutions. And that's where it gets really interesting. People, start building, various solutions for this. And, there's definitely different approaches here, but that certainly requires kind of a dedicated, engineering work stream or kind of a decision to invest in this. And then sort of the last stage, which is scalable, where really, you sort of have the Netflix and the Airbnbs of the world, which have dedicated specific resources to figuring out a very scalable way to provide data quality and reliability, oftentimes across their data stack. So just as an example, Netflix has something called RAD, which is sort of their anomaly detection, which uses RPCA to detect anomalies. There's an interesting blog about this that they released. And that's probably an example of an organization that's very mature in how they think about meeting their observability needs. I think overall, we're seeing more and more data teams, definitely realizing that they need to start thinking about this, and also looking for more automatic ways so that, their teams can actually be relieved of these things and work on more, projects that are, revenue generating or more core to their own business.
Another interesting thing about this particular point in time is that it seems that this is the year that everybody has decided to build a data quality or data reliability company, where I can think of at least 3 or 4 different businesses that have launched in the past few months. I'm curious what it is about this particular point in time in the industry or the economy or the maturity of organizations or the maturity of the platforms that we have available to us that has led to that particular outgrowth and this particular focus in that being a business need that needs to be solved, that there's so much opportunity for that many companies.
Yeah, it's definitely the year of data observability. I'd agree with you on that. And I think it's probably a combination of a few different things that we talked about them, right? One is kind of the drastic change that we're seeing the last few years in regards to how we work with data, moving from a small number of people work with a small subset of data to many people in the organization using data all the time. And actually, I think COVID-19 has accelerated this to a certain degree. We see companies rely on data way more than past. Actually, interestingly, DoorDash recently posted a great article on their data platform. And we're seeing, more and more teams in this day and age thinking about what a great data platform can look like. The second I would say is that sort of, as we mentioned, like the data stack itself and consumers have evolved. We used to work, a few decades ago, just doesn't cut it anymore. If people would tell me a few years ago, I have like 3 or 4 sets of eyes on every single report before it leaves our team. We always have someone who's like looking at the numbers and checking them every day. That just doesn't cut it anymore today. So I think in some ways, like technology needs to evolve as well. And then I'd say sort of the third reason that I see is just the data industry has progressed at a breathtaking rate the last few years. And that you can see in large acquisitions like Looker and Tableau, which we've seen. And then, Snowflake's IPO is an example, just a few weeks ago. We're obviously seeing a lot of exciting changes and exciting times in the data industry at large.
And in your own experience of building the Monte Carlo business and the technology platform to facilitate visibility into customers' data workflows and the issues that crop up there, what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
I'd say probably one of the most interesting is, we're creating a category, right? The data reliability, data observability category. And, we're solving a very big problem that has a broad set of capabilities. But in the end, you really need to listen to, sort of to your customers and to what works in order to figure that out. Few specific things that we found out. One is that actually language matters. And so how you call a problem, how you think about a problem really sort of makes a difference when in speaking to people. And so we've heard that kind of data downtime, data observability is something that people sort of intuitively understand and get it. There weren't that many words or sort of language to describe this. And so we actually had to sort of go through, kind of the process of thinking through what is the language that describes this problem? How do we think about this? How do our customers think about that? And then bridge that with kind of terms like data downtime. I would say the second is that, thinking about data reliability, it's a very, very broad problem. But if you actually break it down into specific pain points that people really resonate with, it's actually kind of the first step to tackling this problem. So specific problems like, getting a call from your CEO at, 7 a.m. on Monday morning because the report looks wrong. That's something very, very specific that people understand and experience if you're in data. And so actually by starting to sort of lay out what are the specific pain points, we can start tackling this problem and think about what a solution to it can be. And the third I would say is that, we've been fortunate to work with some great customers and to really think about kind of this category and this platform alongside with them. They are probably the most important part in this journey. And so, when thinking about this problem, we worked with customers really from very early on. The goal was to get something in their hands and then iterate with them in solving this problem. And I think these sort of some of the sort of key things that have been most interesting and also most fun to work on as part of the Monte Carlo journey.
Do you have any of your own insights on that, Lior?
Sure. Yeah. I think the thing that struck me the most was data is always very specific to every company, and every data incident or data issue is very unique, right? Like each one is like a snowflake and everyone has their own problems. What I was really amazed by is that there's actually a lot of common threads between companies, and we keep seeing the same things break over and over again. And so by really focusing on those particular problems that keep happening, and you can kind of tease out what they are just from the observability pillars that we mentioned earlier, you can actually go and solve a pretty broad range of data incidents, right? Automatically detect them and help teams resolve them quickly and help prevent them in the first place. And to me, that was surprising because when we first started, we were wondering, is it actually possible to solve this problem across different companies, different teams, different type of data sets? And to me, it was great to find out that the answer is a resounding yes. So yeah, that's my lesson from 2 years of working on this problem.
For people who are running their own data platforms and who have their own workflows that they're trying to manage and try and gain visibility into, are there any cases where Monte Carlo might be the wrong choice, or there might be some alternative approach that would work better for them?
Yeah, so I would say definitely one kind of alternative is, actually to not use your data at all or to not rely on data. I would say that's definitely one approach that you could take. The other alternative that you could take is to actually try and build in-house. We see data teams who, decide to kind of focus on this as part of their platform and, put work into building this. There's definitely kind of a cost and effort question of kind of building something like this from scratch. It definitely requires kind of a unique set of capabilities ranging from engineers, data scientists, and more. And so, I think oftentimes for some companies, it can be challenging to justify building something that's sort of complicated and nuanced like this from the ground up. But certainly if that's something that, companies have appetite for, that's an option as well.
And as you continue to build out the platform and work with customers, are there any initial assumptions that you had going into this, or any personal biases as to what you thought the proper solution was going to be that have had to be updated or that have been challenged in the process of bringing on more different workloads or different problem domains or industries?
Yeah, I would say, our customers challenge our assumptions every day. And so if there's something that we learned is that we, can think together about what we think is a potential solution, but then, build it as fast as humanly possible, put it in the hands of a customer and see how they actually interact with. So there's also a big difference between what a customer says they want and what they actually do. So in a sense, I feel like, a company sort of focusing on data observability like us, it's a lot of actually, running a series of experiments with early customers to understand, to validate and invalidate all of the assumptions that we had. One of them is sort of what kind of, Lior spoke about before, which is, what are the different aspects of this problem and how do we attack that? So, in a way, if you think about sort of each of the data observability pillars, we've had a certain set of assumptions about each of them, which data observability pillar matters more and why, which, how to think about the solution for each. And so I would say literally our customers challenge us on those and surprise us on those every single day.
One example that kind of springs to mind, which kind of surprised me, was we always came in thinking that people want to know when things break. And that was true. But what also surprised us is that people really like to know when things got resolved. So apparently in a lot of companies, you kind of hear about things breaking. Some alerts might go off or someone might announce it quite widely, but nobody ever tells you when things are fixed and can be used again. And so that was kind of an interesting learning from working with actual customers, is when we're able to automatically detect that there's an issue and then automatically notify the stakeholders when it's resolved. That's actually a very powerful thing that people really appreciate and get a lot of value out of.
And along those lines, for software applications, there's often the concept of a status page where you can go to if you start to experience problems with something like GitHub or Slack to see, is this down? What is it that's causing this problem? Do you have anything analogous like that for the data domain where you provide a status page of this is causing a problem, this is some of the downstream impacts, this is what our expected, time to resolution might be, or this was when the resolution happened, and have something like the concept of an uptime graph?
Yeah, 100%. If you actually think about what are the different things that go into preventing and mitigating data downtime, there's probably kind of a few key metrics, that we think about. One of them is the number of incidents, right? So how many incidents do you have? What's their severity? What's their impact? That's one important one. The second is time to detection, right? So how quickly have you actually found out about an issue? How quickly have you identified it? How quickly was the person responsible for it notified? There are some people or some organizations where in order to find the person responsible, it can take, 15 or more pings back and forth on Slack to figure out who the right person is and who should be the person on the hook for this data incident. So, that's kind of the second big metric, time to detection. And then the third is time to resolution. So, from the minute that you have a data downtime issue until it's resolved, how long does that take? Is it a number of months, weeks, minutes? And obviously, both reducing data detection, time detection, and time to resolution, as well as reducing the number of incidents overall, is what should help you, increase your data uptime. I also, start seeing companies are actually measuring their data downtime or uptime. And, I think that one day we're going to have like 5 nines basically of data uptime. And that's something that, any data team will need to monitor and to think about and to optimize for.
That reminds me of the old joke of you can have as many 9s of uptime as you want, but I get to choose where the decimal place goes.
Exactly.
Totally. Yeah, absolutely.
And so as you continue to build out the platform and plan for future features or future use cases, what are some of the things that you're most excited by or things that you're keeping an eye out as far as overall trends in the industry or new capabilities that you want to add?
Yeah, so I think it's definitely an exciting time in the market, and there's a number of exciting solutions that we're building out. One of them would sort of touches a little bit about the things that we talked about today, include kind of key assets, which is, sort of a new way to think about what kind of data matters and what data is outdated or no longer relevant. We're going to be publishing a blog post about that pretty soon. But, I think kind of taking a step back, our mission is really to give data teams unwavering confidence to trust their data, so that they're not paged by their CEO in the middle of the night or, kind of forced to reckon with some broken report during a company all hands meeting. And that means that, data pipelines are trustworthy and reliable. Data analysts can use their dashboards and know kind of which, what data they can trust and where it's coming from and who else is using it. That also means that data governance is automated and easy and painless. And ultimately that companies can make better decisions with data. I really think this is the most important kind of trend in the data industry. If you think about it, we have more and more people making decisions based on data, but also starting to use machine learning models to make decisions for them or on behalf of them with data. And so making sure that we have reliability and trust in the data is key to really enabling almost all of the other trends in the industry that we'd like to see going forward.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, starting with you again, Barr, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
100%, I would vote for data observability. Check out some of our recent blogs on this. But, I think data engineering is an area that's moving fast and needs to sort of catch up for software engineering. And I think observability and reliability is one of the sort of key areas to do that. And, more broadly, kind of figuring out how to automate data engineering workflows. I think in the last year or so, it's really started to bear fruit. And for us, that means, automatically sort of detecting and preventing data issues. I'm optimistic about the future of this space. I've seen a lot of different interesting areas with a lot of potential. Excited about the future.
And Lior, how about yourself?
I think one of the biggest challenges in data is actually collaboration. And this is something that's been worked on a lot in the software engineering world. And there's a lot of tooling around that, and the industry is getting increasingly mature with that. But with data, a lot of these problems remain unsolved, right? Like to deliver really great data products, you need to have data engineers, you have to have analysts, you have to have data scientists, and all of them have to work in concert together. And, how do you allow all these different groups and all these different individuals work together at scale to deliver great products that are both useful for the business and also reliable and trusted, right? And data observability is obviously a big part of that.
Well, thank you both again for taking the time today to join me and discuss the work that you've been doing with Monte Carlo and helping to promote the concept of observability for data workflows. It's definitely a very problematic area and one that's good to get some strong focus on that from yourself and others in the industry. So thank you again for all of your time and effort on that, and I hope you enjoy the rest of your day.
Thanks, Tobias. It was fun.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.